Hi guys, welcome to COSC100 tutorial number 1. So this is the first tutorial that we've looked at in COSC100, and we've got a few chores at the start here. So before we get started, we have to set up our machine with the processing software, or we need to install the remote desktop client, the X2Go client, so that we can log in to the Turing server. So if we start by jumping to processing.org here, you can see up on the left-hand side, there's a nice download link for us. You can jump into here. And we've already got that open actually, sorry, and you can see that you've got downloads for Windows, macOS and Linux. So go and download the version of the software for the platform of your choice. I'll be running mine on macOS here today, and get up and going in the practical session. If you're working, if you want to work on our server here at the school, you can go and download the X2Go client software. So here at the Schools of Science and Technology, we have a high-performance server that runs Fedora Linux on it, and you're able to log in, and the desktop that's presented to you is exactly the same as the one that's available in the lab computers here on campus. So once you've downloaded the software from our links, we've got, back on the Moodle page here, we've got two links for you to go and have a look at, the one for Windows and the one for macOS. If you complete the steps in that guide, you'll be able to log in with your UNE details, and you'll be presented with a desktop very similar to this when it decides to come up. Oops, very similar to this. So you'll have a login page. You can jump on in and connect up to, you might get a couple of errors. That one's related to a certificate, and I've already got a session open, so I'll just log back in, and you'll get a desktop that will look similar to this. It's doing a bit of jumping around because I've done too many things at once, and you'll have access to the processing application from the development tab, the development menu under the applications button at the bottom there. So jump in and you'll be able to use processing to complete your assessment tasks. So jumping back to our exercise, today's exercise, the first part is to complete the hour of code tutorial for processing. So I'm not going to go through that one with you. You can work through that in your own time, and it's just a demonstration to get you started using the processing environment. The second task takes you through the debugging tutorial. Now, if you want to go back to these, they're all available on the processing website. Just let me zoom in on that a little bit more for you. And they're under the tutorials item at the side there. So you've got the Hello Processing Hour of Code. There's a few other ones in here that you might want to have a look at. One that might be useful is the interactivity one, as it'll run through using the mouse and keyboard as well. So have a play around with those, and let me know if you have any questions regarding those two videos. We're now going to move down to item exercise number 3, and here we have some programming exercises for you to complete. So over here on the left hand side, I've got my processing window opening, and you can see that in processing, you would have seen me in lectures, we've got our run button, our stop button for running our code, we've got our console situated here at the bottom, and we've also got our debug button up in the top right. But we'll kick on in with our first program here. So on a window of 300 by 300 pixels, construct a red quadrilateral. So first of all, I'm going to start by using the size function to set up my my window. So I'm just going to make my text a little bit bigger so you can see what's going on here. So I'm going to use the size function. I'm going to have an width of 300 and a height of 300. And then we're going to draw a red quadrilateral. Now, I can't actually remember the function to look at a quadrilateral, so I think it's quad, but I'm going to go check the reference. So if I jump back to the processing website and click on the reference link here at the top, you can see that we've got a big long list of different functions and bits and pieces that processing gives us. And under this 2D primitive section is all of our 2D shapes that we can draw. So lines, points, ellipses. And you'll see this quad function. So if we jump into here, you can see that we've got the basic syntax for the quadrilateral function, or the quad function, listed with what it expects. And we've even got an example. I'm going to grab that example straight away. I'm going to drop him straight into my code. So if I go and run that, you can see that I get a window popping up and I've got my quadrilateral in that window. Now, I might make that a little bit bigger, so I need to go and move some shapes around here. So I'm going to make this one go a little bit further across. I'm going to make that 186, 20, and then 69, 63, which is going to be that point. I'm going to send that down a little bit further to make my quadrilateral a bit bigger. So there you can see. So I've drawn this awkward shaped quadrilateral. And the second part of our question, is to construct a red quadrilateral. So to make that red, I'm going to use the fill function. So if I go use the fill function, now the fill function, again, we can go and look that one up on the reference for processing. If we drop back in, you can see up in the top right hand corner, we've got the fill function, and the fill function takes either an RGB, a single value, or you can specify the red, green, and blue color values in there. So I'm going to use the red, blue, green color values, but I'm not just going to use a really basic red. I'm going to go to the color selector, and I'm going to select a nice, pretty orangey red, I think. So something like that. You can see that I've got the RGB values, so that's 255850. So if I drop those in here, 0, I should get a nice, and I've got to remember my semicolon. If I quit out of that one, I should get a nice, well, now it's an orange, but very close, orangey red quadrilateral. So that's that exercise complete. So using the size, fill, and quad functions, we can draw a simple quadrilateral and color it red. So I'm going to clear that away, and I'm going to move to the next exercise, which is part B. So in part B, we're creating a window of size 100 by 300, and we're drawing a line from top to bottom that has a weight of 5 and a color of green. So first of all, I'm going to use the size function to set up my window. So I'm going to make it 100 wide by 300 tall, and I'm going to draw a single line. So I'm going to use the line function. Now the line function takes the start point and the end point. So if we jump back into our documentation, you can see that we take our start and our end point. So I'm going to start it at the middle at the top, so I'm going to use width divided by 2. I start at 0, and then I'm going to take it down to width divided by 2 height. I'm going to use the height variable. So what this is going to do is draw a single line down the middle of my window if I've done that properly. So you can see I have a little black line straight down the middle of my window. Now, the second part of that question asked us to color the line green. Oh, and I've got to change the weight, sorry. So I have to change the stroke weight of my line. So I'm going to use the stroke weight. Stroke weight function, and I'm going to put a 5 in there, and then I have to give my line a color. So I'm going to use the stroke function to give it a color, and again I'm going to go back to my color selector, and I'm going to pick a deep dark green, or maybe a little bit brighter, so 23 165 17, 23 165 17, and I'll put some semicolons on the end of our statements. And if I get rid of my color picker, run my code, you can see that I've got this nice green line running right up and down from top to bottom through my canvas. So that's the solution to part B. So let's clear that one off. Let's have a look at part C. So on a window of 400 by 400 pixels, we need to create a circle with a radius of 30 pixels that moves back from left to right. So we'll need to implement a setup and a draw function, and we can use this code that we've got below here as a starting point. So let's go and just drop our starting point code into processing. So if we go through here, you can see that we've got this floating point variable. We'll just leave him here for the second. So let's have a look at our size function. Our size function is only going to be creating a window of 100 by 100 pixels. So we'll change that to 400 to give us a bigger window. And we're filling it with 0, so our fill will be black in this case. I don't think we've specified a color. And we need to draw an ellipse that is 30 pixels. So we want to change the size of our ellipse. So if we go back to our reference here and go to the ellipse function, we can see that A and B are the x and y coordinates of the ellipse, so that's the center point of our circle, and the height and the width and height are the parameters C and D, so the last two parameters. So if we change this to be a radius of 30 pixels, so if we change this to 30, well, I'll just check, is that radius or diameter? So it's the height, so it's the diameter. So to have the radius, we actually need to double that. So we need to have 60 there. And when we run our code, let's see what we get. So you can see we've got our ellipse going here, but you can see it stops and goes back up to the top, and it doesn't make it all the way to the bottom. And that's because we haven't actually implemented the condition that resets it correctly. So it moves from left to right on the window. So we need to actually update the x value. So I'm going to change the name of this variable to x, and I'm going to call it x. And we want x to reset if x is greater than 400. This becomes minus 50. So if we go and run this code, oops, we've got to just quickly reset that one. I'll put it in the middle of the screen, so we'll use height divided by 2, and we'll put the center point of our ellipse as x. So now we're moving across. We're on the x-axis instead of the y-axis. When we move here, we can see that our item slowly moves across, and when it gets to the other side, it will ultimately start moving back again to start from the other side and go again. So it needs to move back and forth. So if it's greater than 400, it'll actually need to you need to switch around. Instead of adding to this, we need to subtract from it. So what we're going to do is keep track of the direction. So we'll have a Boolean variable called left equals false. So when it's going to the left, we'll set that to true. So if left is equal to true, if left is equal to false rather, we will want to move to the right, so we're going to increment x, put some brackets around that one. Otherwise, we need to swap around the direction this one goes. Oops, I'm going to drop that in there. So now what we're essentially doing here is switching the direction around. So if it's left, so if at any point you don't need this one anymore, we go left equals true. So we're moving back to the left. And we need to put another condition here. If x is less than 0, So now we should be able to run our code and see what happens when it gets to the other side. So it should change direction if we've done this properly, but we'll see how we go. We might have made a logic error. Even if we have, we can correct it. So it goes the other side, and then it goes back across. And when it gets to the other side, it should change and go back again because this condition will be true. So essentially, we're alternating between left and right based upon that condition. So we should come back, or not. X probably never gets less than 0. So what's going on here? It's because we didn't set that properly. We've got a logic error. So we'll quit out of this one, go back, and we'll change that to false. So now if we run our code again, we should have that one sorted out. I'm going to go and make it run a little bit faster, just so we don't have to wait so long. So it should bounce from left to right, hopefully. Let's check and see if we got our logic correct now. That looks a lot better. So that gives us a solution to part C. So let's go through now. Let's have a look at part D. So we're modifying the code from the previous question so the circle moves back and forth between the top left and bottom right. So top left and bottom right. Now this introduces essentially the y variable. So we're going to start by creating a variable to keep track of the y direction. So we'll start it at 0. So we need to start at the top left corner. And we'll need to then, so again we need another set of conditions similar to these to switch around. We might have boolean so we create a boolean variable to keep track of if we're going up. There we go. If up is equal to false, so you'll notice that I'm using the equality comparison operator, not the assignment operator. So if we want our item to go down, we'll have y plus equals 1.5. If we want to go back up to the top, we need to subtract 1.5 from that one. So that's got our y variable sorted. So now we need to keep track of when we reach the top and bottom. So here we'll have another version of this, but with our y variable. So if y is greater than our height, and our height is 400 in this situation, that's fine. If our y is less than 0, up equals true, up equals false. So now, if we go and run that, we can see what happens. Oh, we haven't got that quite right because we haven't updated the position in our ellipse, which we can do by dropping y into there. So let's go and have a look and see what we've built. If we look here, we should get something that will bounce back. There we go. So in summary, what we do in this example is keep track of both the x and the y coordinates and whether we're going across, whether we need to switch, whether we need to turn around, or whether we need to turn around in the x or y direction. And then we simply have some conditions in there to control whether we're going up or down or left or right. And we do that by subtracting or adding values. And then we have some code there that detects when the bouncing ball hits the side of the window. So a fairly straightforward example, but just getting you using those control structures. So that's question 3 covered off on. Let's have a look at question 4. So here we have an example from lecture number 2. So we're rendering some bits and pieces here. We're setting up our canvas and then we're drawing some random lines. So let's have a look here and go and run our code. So we'll drop that, get rid of it. Let's run our code quickly. So you can see that we've got these nice random assortment of lines appearing from left to right. So essentially we want to modify that so that they start appearing from the top right hand corner. So they start moving from right to left. So all we need to do is, first of all, we start in the top right hand corner by setting I to be the value of width. Then we go, if I is greater than 0, we subtract instead of add. Otherwise otherwise we reset it to the beginning. So all we've done is flip around the direction. So now when we run that, oops, we haven't quite got that right. Why haven't we got that right? So we started mid-flight, I think. So have we initialized I correctly? So what's happened there is that we need to go down and actually put I. So recall that before we set our size, you'll find that before we call the size function, the default size for a canvas is 100. So it means that at this point in our code, the value of 100 will be saved into I. So all we need to do is put I there and then have our I equals width down here. When we go and run that, that should sort out that little glitch. There we go. So now our lines are appearing from the right hand side, moving across to the left, and once they reach the left hand side, we should end up with the code starting again from the right hand side. So here's hoping we've implemented that correctly, and it appears we have. So that's got an answer for question 4 done. So you can play around with the color schemes here. So the color is controlled by these random variables in the stroke function. So recall that the stroke function takes a weight and also some colors, so RGB colors, and we're just randomizing the RGB color values. So if you mess around with those, you can get some different colors occurring in there. So here we've added some more red in and we've got some pinks. We can take some blue out and make them more red and green. We can take some green out and make them all reds. So by adjusting that color scheme, you can essentially manipulate what appears what color the lines are rendered through the random function. So just a nice little bit of playing around with some generative art there. So that covers off on all that I'm going to run through for the tutorial 1 video. The Space Invaders run through can be found in lecture number 5, and we'll go through that a little bit more next tutorial. So thanks for listening, guys.